Hello friends, good morning to all. Today we are going to learn new topic of unit number 2. Name of that topic is structure of solids. Uh, in a 12th standard you had won that topic. You had already learned that topic in a 12th standard, that is solid state, that is chapter number 1. So you are even in a FY as well as SYPSC there is also some content about the solid state. So we are not going into detail about the basics of solid state chemistry, right? Because we had already known that what are solids, what are different types of solids, then what are the forces involved in it. So that terms we will just go quickly into that particular things. So what are the content of this chapter? In this chapter we are going to see, that is some introductory part of solid state chemistry, some important terms, classification of crystalline solids, crystal lattice and unit cell, close packing of rigid sphere, packing efficiency, as well as some calculation for calculating density of unit cell, then defect in a crystal structures and its magnetic and electrical properties. So these are the basic content of this chapter. We will discuss that in this topic. Before going to start about the topic, let me distinguish first crystalline solids and amorphous solids. These two are the types of solids. Uh, my basic question to all of you is that if I ask a question, that is what is solids, or what are the three different states of matter, or what are matter, so I will give the answer of each and every questions. What is matter? First, anything which occupy a space is called as matter. Anything, for example, if you took, let's say, a book which occupy a space, the book become a matter. If you take water, if it occupy a space, for example, if you take water in glass, it occupy a space in glass, so it become a matter. Or air, when air, if you consider in an environment, that air is also one type of matter which is occupying a space. So in simply, anything which occupy a space is called as matter. Okay, now that matter is exist in three different states. One is solid state, second one is liquid state, and third one is a gaseous state. Out of the three states of matter, if you try to define all these three states, then on the basis of arrangement of constituent particles in that matter, we have categorized matter into three classes. If the arrangement of constituent particle is very regular, tight, rigid, then that particular matter is called as a crystalline solids. Or if the intermolecular force of attraction between the molecule in a solids, if it is very high, then obviously there is a definite arrangement, right? So that solids are called as a, that is called as a solids. Then in a liquid, that arrangement of constituent particle is, it is a not in that much extent like a solids. So their electrostatic force of attraction between two atoms or two molecules in a liquid state is slightly less as compared to solid, but more as compared to gases. If the intermolecular force of attraction between two atoms of that matter, if it is very less, if there is a irregular arrangement of that constant particle in space, if there is a large distance between two atoms, then obviously that type of matter is called as a gaseous matter. Okay, now coming to the solids. As I said, solids having definite size, shape, volume, their constant particles are definitely arranged. They are having very strong intermolecular force of attraction. If you know that are the important characteristics of solid, then distinguish that type of solids. So basically we have two types of solids. One is called as crystalline solids, another is a amorphous solids. So what are crystalline solids? Let me distinguish by point wise manner. First point, crystalline solids have definite characteristic shapes. That means if you take a example like salt, NaCl, sodium chloride, this NaCl molecule is a crystalline solids. Why? Because it having definite characteristic shape. For example, NaCl having a cubic structure, cube-like geometry. But amorphous solid does not having such a characteristic shapes. That means they have irregular shape. For example, I will take calcium carbonate or chalk. It is amorphous solid. Their constant particles are not arranged definitely. Right? Second, they have long range order of regular pattern of arrangement of constant particles. That means in a crystalline solid, constant particles are arranged regularly to the long distance. For example, in case of NaCl crystal, Na plus, if it is present at one point, then there will be Cl minus, again Na plus, Cl minus, Na plus, Cl minus. That means that arrangement is found regularly. You can see here. Suppose if I write here Na plus, then next will be what? Cl minus. So that arrangement will be you can find regularly there. Alternate cation and anions are present in NaCl crystals. So that arrangement is a regular arrangement and it is a present in a long range. Such a arrangement is not found in an amorphous solid. They having short order of regular pattern of arrangement. So their arrangement is not a regularly. Third point, crystalline solids are true solids. Amorphous solids are pseudo solids or supercooled liquid. Why crystalline solids are true solids? Because they are having characteristic properties. Such a characteristic feature is not seen in amorphous solids. That's why it is called as a pseudo solids. Their properties can be changed. Fourth, crystalline solids have sharp melting point. For example, if I have NaCl crystal and if that NaCl crystal is, let's say, melt at 100 degrees Celsius, so obviously if you take any NaCl crystal, if it is pure, it is always melt as a 100 degrees Celsius. So that is a sharp melting point. While amorphous solid does not having sharp melting point. Means if you have chalk and if you melt that chalk, if its melting point is let's say 500, it started to melt at 490 or it started after 510. So our melting point is not sharp. Crystalline solids are anisotropic in nature. You know anisotropic phenomena, that is also you had learned in a previous classes. That means anisotropic phenomena is like uh, the physical properties of a crystals does not change with it, remains as it is because of there is a regular arrangement, right? Such a anisotropic effect is not seen in a amorphous solid. There is isotropic effect. Okay. That means when you go in a crystalline solids, there is a perfect arrangement of constant particles, and therefore its physical property does not change with change in direction. But in amorphous solid, its physical properties are changed with change in direction. And last distinguished feature is that crystalline solids have definite heat of fusion. That means it melt at fixed temperature, while for amorphous solids they does not having fixed heat of fusion. Now these are the basic things of solid state chemistry, but as I said, in our TYBSc syllabus we want to learn some advanced topic of solid state chemistry. So in introductions we will see that one question that will be mind in your, that is why only solids are focused or solid states are focused in the syllabus, because most of the solids, as I said earlier, most of the metal or most of the element in periodic table they are present in a solid state. That is one thing. And second thing is, in our surrounding also lot of materials are made up of solids, that you have to keep in mind. And third important application of is the symmetry. The important application of symmetry is to determine the structure of crystalline solids. If you have a solids, if it is a crystalline solids, then there could be a symmetry. If any solids which having symmetry, then it is very easy to determine the structure of solids. That is one thing you have to keep in mind. That is the important application, because in last topic we studied the symmetry elements or symmetry operations. Every solid having a lot of solids we saw there as there is a symmetry. So solids play a vital role in the progress of mankind. Today, as we saw that this is the modern era. So in this modern era, mankind, whatever the progress of mankind we seen, all this because of lot of technology or sciences. So in that solid play an important role, because every day new type of solid materials are formed and they having a very good or very interesting properties. So solid state chemistry is very important branch of chemistry. Today science and technology develop a variety of new material of desired quality. As I said, science and technology have developed a variety of materials, nanomaterials also. That is of what? That is of a solids. We have many examples like semiconductor, laser, ferrites, magnetic garnets, magnetic bubbles, solar energy converter. All these are what? All these are very highly uh, important field in today's day, and therefore all these materials are the inorganic compounds, and most of the inorganic compounds are solids. Similarly, a properties of solid like color, magnetic and electrical properties, it also depends on electrons. We are considering inorganic chemistry. So in inorganic chemistry we have four uh, block in a periodic table, and all these four block, if you saw there is a variety. Like in S block there is metal, in P block there is some non-metals, D and A block there is transition and inner transition elements. So This such a variety of metals when combines, when they form alloy or when they are alone, they shows a very interesting properties, and that we are interested today. The nature and final properties of material we use every day depends upon the atomic and molecular structures, the degree of order and perfection in the structure, and the forces and energy associated with them. So it is very essential to understand solid state chemistry. Now, to understand the solid state chemistry, we have to learn first some important basic terms which are involved in it. Without understanding that terms, we will not going to learn what is solids, or we are not able to understand the you will not able to understand the what are solids. So here first term is crystal lattice. Now if I ask what do you mean by lattice? Lattice means a network. So network, if there is a many constant particles, if it is present in a solids, they should be arranged in a particular fashion. So crystal lattice is an orderly array of repeating unit. That means if I, as I said earlier in NaCl, if I have NaCl, there is a fixed arrangement that is called as orderly arrangement of constant particle. Like first at one point there is Na plus, then after there will be Cl minus, again Na plus, again Cl minus, again Na plus, again Cl. So every Na plus is surrounded by Cl minus, and also every Cl minus is surrounded by a Na plus. So that arrangement is what? Orderly arrangement. Similarly, in a crystal lattice, lattice is a giant structure. It's a very big structure which contain n number of unit cell. So if that unit cells are arranged repeatedly, you will get the crystal lattice. So crystal lattice is a three-dimensional arrangement of constituent particles which are represented as point. Every time we are not able to draw the unit cell, so one point indicate what? One unit cell. So that point, if you arrange in a space, then it is called as a lattice point. I will tell you here. Suppose I have considered this is a point. This point indicate what? It is a unit cell. This is another point, another unit cell. So these unit cells are arranged in a three-dimensional manner in a space that is called as space lattice. That is called as space lattice. And what is crystal lattice? Orderly array of repeating units of repeating unit cell, that is called as a crystal lattice in a which form a network. For example, let's say I have this diagram. This is a cube. This is one unit cell. So same unit cell, if it is present like this way, it is very difficult to draw, but I will try. So this is another unit cell. So such a unit cell, if you arrange repeatingly in all direction, then there is formation of crystal lattice. So space lattice is an array of points. So these are what? A point. These all are a point where called as a space lattice. It shows how particles, that is ions or molecules, are arranged in different sites in three-dimensional space, so that nature of spatial arrangement is clear. What is spatial? That means there is a arrangement which is in a three-dimensional, or this which is in a particular fashion. Everybody understood crystal lattice and space lattice? Now next term that you have to understand, that is lattice point. As I said, the point at which particles are present, or the point at which particles are arranged are called as a point, are called, that is point, the position occupied by particle in a crystal lattice is called as lattice point. So as I said, if I have, suppose this is a one kind of crystals, so here I have arranged such points. So these points are what? Actually there is an arrangement of some ions or molecules like Na plus, then Cl minus, then Na plus. So that arrangement will be seen on that point. So that point is called as a lattice point. What is unit cell? It is the smallest geometrical portion of crystal. So this is the crystals. In that crystals, if you consider this small portion, that portion is called as unit cell. This is one unit cell. This will be another unit cell. This will be another unit cell. So there is many unit cells which are present in a crystals. So a smallest geometrical portion of crystal is called as a unit cell. I will tell you one example. If I have a big size of sodium chloride or a salt, in this big size of sodium chloride, if you divide that into a small size, you will get a sodium chloride of crystals of small size. So likewise, if you divide that molecule into smaller portion, at one portion where that portion is not going to break down, so that smallest portion is of that crystal is called as a unit cell. Just like the definition of atom is the smallest part of the matter which is not going to divisible. So like unit cell is also not going to divided. Okay, now what is lattice constant? Lattice constant is the unit cell where there is three important edges are present, that is ABC. I will tell you here. Suppose I have, this is a unit cell. So these are the edges like A, B and C, if you consider this as a point. So these are the three important edges of the unit cells, and that edges are away from each other by some angle. That angle is called as alpha, beta, gamma. The angle between, let's say, A and B is called as alpha, C and A is called as beta, C and B is called as gamma. So that angle and edge length which is used to describe the structure of unit cell is called as lattice constant. Everybody understood? A real crystal is a three-dimensional arrangement of unit cell, and that crystal has a same type of symmetry as like unit cell. As I said, if I have a big size salt which having, let's say, salty taste, small size salt also having a salty taste. That means whatever the properties of crystal have, same properties can be seen in a unit cell. Okay, because unit cell is a part of crystal. Okay, so that you have to keep in mind. So we saw a definition of crystal lattice, space lattice, unit cell, lattice point, lattice constant. Because sometime question may be asked, define the following terms. Most time it is asking. Therefore, I have given you with all these definition with their diagram or with their proper explanation. Okay, so this is enough for today's lectures. Thank you for watching.